Aarti, thank you so much for joining us at our Target ALS Annual Meeting.
Great to be here.
It's so good. I'll go right ahead.
Fantastic community. It's wonderful to be part of. It's a real family after so many years.
Well, it's great to be back in person as well,
Yes.
to see you again,
Yes.
since we were all virtual last year.
Exactly, yeah, no, it's good to be here. I feel like nobody has changed, but the science has changed, and we've kept that moving through the pandemic, which has been great.
I'd love to know, how has the science changed?
The science, I feel, at Regeneron, we've made huge progress. When I first started at Regeneron about 5 years ago, we were very nervous. We were skating around the edge of neurodegenerative diseases. And now I think we're fully committed to therapeutics. We started with a lot of early discovery initiatives, and now we're ready to jump in and really push things forward and hopefully provide a valuable therapeutic to this community that desperately needs it.
What do you think some of the, if you were to pick one thing to say is the most promising that out there? Maybe it's hard to say one thing, but
we are very close for tailored therapeutics for some of the genetic forms of the disease. For me, some of the most promising and exciting things have been our work on sporadic ALS and understanding the movement of TDP-43, which is this major protein that's aggregated in sporadic ALS. So for us, I think we're on the cusp of hopefully releasing some of that work this year, and that will lead to us providing tools and reagents for this community and hopefully advancing a therapeutic.
You mentioned TDP-43,
Yes.
so for the audience at home, in case they don't know what that is, do you mind explaining?
Yeah, so in our bodies we have this normal protein that exists. It's called TDP-43, and it binds pieces of RNA in our body and it helps our body synthesize proteins. So it's like a master regulator of our genes, if so to speak. Now in disease, this protein, which is normally in the nucleus, the powerhouse of the cell, it leaves the nucleus, it mislocalizes, and it forms these clumps in the cytoplasm of our cells. Nobody knows what effect that has on those cells, but our hope has been to try and understand what that mislocalization and aggregation does to a cell and how that could lead to motor neuron diseases such as ALS.
Sure. And it takes a lot of resources and
Yes.
tools to be able to even
Right.
understand that.
Yes, exactly.
Have you used any of the Target ALS scientific course?
Yes, we have leaned heavily on the Postmortem call. We've requested a lot of samples. It has been a dream to work with folks. They have been very patient with me requesting certain mutations. And we have also leaned on some of the antibody reagents that have been produced, in particular poly-GP, which is found in a very specific genetic form of ALS linked to C9orf72 repeat expansions. So we've taken full advantage of those services.
Oh, terrific! Yeah, I'm glad to hear you've used the postmortem tissue core. You know, we're proud of it, knowing too that prior to it, it was very hard to get samples.
Right.
So you could do incredible research,
Right.
but you hit a certain point and you don't have the tool you need. So we're lucky enough to be able to expedite that for everyone with open access for all scientists. What do you think is missing in ALS research?
I think still there needs to be some depth in understanding sporadic ALS. I think we have really good handles on some of the genetic forms of the disease. And I think we all have a lot of ideas. We're all great scientists that work on this problem. And I think if we could put our heads together and collaborate a little bit more effectively on this really, really big problem of sporadic ALS, we could cure this disease potentially, which I think we just need to sit down, get the best minds in the room and talk. And I think that's what this meeting does. And it's just good to have a little bit more of it.
I agree with you. Walking around the ballroom, it's amazing to see the leading ALS scientists, faces I recognize, just being in the space, and also those of us who are joining us online through our virtual program as well.
Right.
So what would you say, moving forward, one thing that I wanted to raise that's a buzzword is biomarkers.
I know.
And we say, if only.
I know.
So could you explain for people, I think, especially for just the general community, it can be a little confusing what a biomarker is. How would you explain it?
Yeah, absolutely. To me, a biomarker means we can track or predict when someone would get ALS. if we saw something increase or decrease in someone's blood, serum, CSF, that's your spinal fluid basically, we can then intervene at an earlier age. We can track if that drug is working, we can track how disease is progressing. It's probably the key to ALS in terms of effective therapeutics and making sure that they're working. Our field really does lack initiatives that are broad enough to discover biomarkers, and that is one thing where I think Target ALS has been phenomenal. They have really encouraged us to go out, be agnostic, and find something that we could use to predict how effective our treatments could be.
Yeah, we are very lucky that we have several programs going on targeting biomarkers. We know how critically important it is. You know, it's made such a big difference in other disease areas. You think about heart disease,
right?
Think about HIV, think about diabetes and cancer, and it's had transformative impacts on those diseases.
Exactly.
And to your point, we truly believe it can change the future for ALS.
Agreed. I think the dream is to be able to intervene at this disease at the very earliest point, and without understanding what that switch is, and that is determined, I think, by a biomarker, that will be the key to leading to a cure for this disease. So
that's our hope.
Yeah, my hope too. Yeah.
Thank you, Aarti. It's so good to see you.
Yeah,
really
great to see you
appreciate it.
too.